Hey guys, again it's me Hiral Shah and hope you love watching my videos regularly and I'm starting my today's sessions and before starting today's session previously we just completed one of the new method which I have started in previous session only, and the name of the method is continuous functions, right? So in previous lectures we discussed about the continuity of the functions, right? And now today again I am going to start one more new method, and the name of the method is differentiability of analytic functions. Okay guys, so uh, before doing these all the sessions, previously when I started analytic functions, at that time I memorized some highlights of the analytic functions, right? Like limits, continuity, differentiability, Milne's theorem, analytic functions, and etc. So at that time I've told you that these all are vice versa, yani ki limits, continuity and differentiability. So it is actual based on the CR conditions only, yani ki based on the analytic functions only, because it's totally depends on analytic functions. Why? Because to prove analytic functions, to find the analytic functions, we need to apply CR conditions, and on the basis of CR conditions we are saying the whether the given function is analytic or not. And then after, uh, if the function will be analytic, then we can say that the limit exists. Now if the limit exists, then we can say that the given function is differentiable, and if the function will be differentiated, then we can give the conclusion that the given function is continuous. So these all are connected with each other. Okay, so same topics we are going to conduct today. One of the and the name of the topic is differentiability of the analytic functions. So here the that rule is the same. Okay, that if the functions will be analytic, then it will be differentiable. Okay, so this one is the same sentence, but the formulas will be different. Okay, so here I have given one of the main formula of differentiability, that how we will differentiate the functions. So here I have written its definition, that a single valued function f of z is said to be differentiable at a point z equals to z0 if f dash z0, z0 will be your one of the point which will be given into the equation, that you have to find at the point 2, 5, -1, 0, etc. Okay, so this one will be given into the equations. So z0 will be your given point. So f dash z0 equals to limit delta z raised to 0 f of z0 plus delta z minus f of z0 upon delta z exists. So this is a formula to find differentiability. So this is a main formula guys, and in the examples we are going to apply this formula only. Okay, so this formula you have to remember, and this is at the point z equals to z0. Now here I have written one of the note. Derivative of f of z at a point z0 can also be written as, this one is another way of representation of differentiative. So f dash z0 equals to limit z tends to z0 f of z minus f of z0 upon z minus z0. So this is one of the way to represent the differential equations. So I hope you all understood guys, and this one we are going to represent in examples only, and this one will be at the point z0. Now continuing with the examples, and here I have written, find the derivative of f of z equals to 1 plus z upon 1 minus z by using the differentiation at z equals to 2. Okay, so here the main function is given f of z, and it is given 1 plus z upon 1 minus z. and you have to use the definition, and this one I have written here. In the definition it was let me highlight, let me write, in definition it was at the point z0. Okay, so where I have written here z, where it was written z0, but here you can see that the definition is given at the point z equals to 2. So the notation of z0 is given here on the z form. Okay, so in place of z0 I am going to represent z, and z yani ki 2. So first of all I am writing its formula for the z function. So f dash z equals to limit delta z tends to 0 f of z plus delta z minus f of z upon delta z. So in place of z I have written, sorry, in place of z0 I have written here z. Okay, now it's given a point that the value of z is given at point 2. Okay, so I'm going to substitute this value in this formula. So it will be z dash 2, sorry, f dash 2 equals to limit delta z tends to 0 f of, in place of z we are going to represent 2 plus delta z as it is, minus in place of z again we will put 2 upon delta z. Now here we are having a function 2, there are one of the function is given 2 plus delta z and another is given for the f of 2. So in place of see in this function, once we have to apply 2 plus delta z, and once we will put 2. Again repeating guys, in this function this is actually your function f of z, right? Now see f of z is given 1 plus z upon 1 minus z. So 1 plus z, z यानी कि यहाँ पे क्या है 2 plus delta z. So here it will be 1 plus 2 plus delta z. This is actually being this one. I hope you are getting guys. Again repeating, f of z is given actually here f of 2 plus delta z. So in place of z we will put now 2 plus delta z. So it will be 1 plus z, z yani ki this one, 2 plus delta z, and the below parts 1 minus z, 1 minus z yani ki again same part 2 plus delta z, minus as it is f of 2. Now in place of z you have to put 2. Okay, this one. So in place of z now I'm going to put this one, yani ki this here also. So 1 plus 2 upon 1 minus 2 upon delta z, that will be as it is. Now we have to, this is the main step only, I'm giving some highlights. This is your main parts guys, because now you have to just do the, just a minute guys, this is your main part, because now onwards in every steps you have to just simplify the term. And you can see here uh, opening the brackets you can write here this limit as it is 3 plus delta z, or here we have to subtract, so 1 minus 2 yani ki minus 1 minus delta z. Now in the upper parts 2 plus 1 yani ki 3, and the denominator will be minus 1, so that will be minus minus plus yani ki 3. So from now you have to just simplify the term, and the denominator delta z will be as it is. Now just taking LCM, and this one will be, I'm going to shift here. So you have to just take an addition or subtraction, and at the last after the simplification you will get this kind of term. And here you can see that in the function it's coming delta z, and of course we having a limits delta z also. So in place of delta z now we are going to shift 0, so it will be 2 upon 1 plus 0 yani ki 2. So this is your final answer. So hope you all understood guys. Now moving for the next example. The question is given, show that f of z equals to iz cube is differentiable for all z. Okay, so here it's not given any kind of function, any kind of point, sorry, not function, it's a point. So that is not given any kind of point, but the function is given, right? Okay, no problem. We will start with the function only, and by applying the definition. So f dash z equals to limit delta z tends to 0. Again I have written, guys, in place of z0 I am going to shift, I am going to write z only. So limit delta z tends to 0, f of, in place of z0, z. So z plus delta z minus f of z upon delta z. Now we are having a function iz cube. Yani ki in place of z you have to put one by one this function. Once you have to just a minute, guys. Once you have to put z plus delta z, and then after you have to put z. Okay, so I as it is z cube, z yani ki z plus delta z cube, minus again I as it is z yani ki z cube. Now you have to open the bracket, yani ki a plus b whole cube, right? This one already you might be aware from this equation that what will be the expansion of a plus b whole cube. Then also again I am repeating, guys, a cube plus b cube plus 3a square b plus 3ab square. Again repeating, guys, a cube plus b cube plus 3a square b plus 3ab square. So in place of this, yani ki here we have given in place of a it's given z, and in place of b it's given delta z. So z cube plus b cube yani ki delta z whole cube plus 3a square yani ki z square into the b yani ki delta z plus 3a yani ki z and b square yani ki delta z whole square. So hope you all understood, guys. Minus iz cube as it is upon denominator also as it is. Now opening the brackets, now multiplying this I into the bracket, so it will this both term will be removed, iz cube and here iz cube, and I'm writing the remaining terms. And also you can take a common delta z from the numerator, so it will be cancelled out from numerator as well as into the denominator. So the remaining term will be this one, and in this equation you have to apply delta z tends to 0. So in place of delta z I'm putting 0. So this one will be 0 and this one are going to be 0. So the remaining term will be 3iz square. Okay. So here we are getting the number. So the given function is differentiable at the point I3iz square. So now we are doing one more example, and the question is given, show that f of z equals to z into imaginary parts of z is differentiable only at the point z0 and f dash 0 equals to 0. So here you have to show the given function is differentiable. Okay, we will go see there is given one point and also it's given a function. So applying the function f of z, that will be z into imaginary parts of z. So in place of z you know the values of z, that is x plus iy, as well as imaginary parts of z and z yani ki x plus iy. And here you have to write the imaginary parts of this one. So of course it will be y. So x plus iy as it is, and here it will be y. Let me highlight, guys. The imaginary of this one will be y. Okay. So now applying the definition of differentiability, f dash z equals to, see again, guys, in place of z0 I'm going to apply z only, because here it's given a z point. So f dash z equals to limit delta z tends to 0, f of z plus delta z minus f of z upon delta z. Okay, now you all having a function this one, so I'm going to apply this. and here it's given f of z. So in place of z, now you are going to represent z plus delta z. So first of all, I'm going to represent this function z into the imaginary parts of z. So in place of z, now we'll write z plus delta z. So I have written into imaginary z, z यानी कि this one, right, minus. अभी यहाँ पे क्या करना है, सिर्फ z की जगह पे z ही लिखना है. So of course the function will be as it is, z imaginary z upon delta z, keeping as it is. Okay, now you can see that we have just gave some simplification of this z into the imaginary z. Okay, so directly I am going to put this value after this one. So this limit delta z tends to 0 as it is, z plus delta z, z यानी कि x plus i y, delta z यानी कि delta x plus I delta y. This is let me highlight with the pen. Okay, z यानी कि x plus i y and delta z यानी कि delta x plus I delta y. Okay, now imaginary of z plus delta z. So in place of that, imaginary parts of this one, यानी कि इसका आपको क्या लिखना है, imaginary parts. Okay, so definitely it will be in the form of y. So it will be y plus delta y, because z का imaginary part है y and delta z का imaginary part होगा delta y. So it will be y plus delta y. So this one will be this. Now minus z यानी कि plus iy in the imaginary parts of z, and z यानी कि this y. So hope you are getting, guys. Now delta z यानी कि delta x plus I delta y. Now we have to just open the brackets. So I am opening the brackets, guys. See, x plus iy I am writing together. This x plus iy I am writing together. So x plus iy into the y. अब इसका इसके साथ multiplication. Now the x plus iy multiply by delta y, यानी कि this one. Okay, now I am making a circle of these equations, and this one multiplied by y, and then after delta y. So delta x plus I delta y, this one multiplied by y plus delta y. Okay, directly I have written this both the terms, or as you can expand also. Okay, and but here I have written it's together. Now minus as it is, and this one also I am keeping as it is. Okay, now next, see guys, here you just have to simply give the simplification, nothing more than this. Now see, first and the last term will be cancelled out. Okay, and the remaining terms you have to write now. So this one terms I am keeping as it is, and here this one term I am keeping as it is, यानी कि one of the term will be this, and the second term will be this one. Okay, so this both term I am writing here as it is, and the denominator again keeping as it is. Now next we have to open those all the brackets. These all the brackets you have to open now. So after opening the brackets, there are so many terms which are not going to cancel out, right? But you can see the limits, its limits given of delta z. Okay, so directly we can't put the terms, because we all having a terms in x and y form. It's not given into the z form. Okay, so for this, to solve this kind of terms, because here you are getting you may see that here we are getting so many terms, and which is not going to cancel out, right? So for that I am going to apply two paths for this. यानी कि first one path I am going to apply for the parallel to x axis and parallel to y axis. Here I have written, guys, you may see that. See, two paths I am going to apply. First one line I am going to apply parallel to x axis, and second I am going to apply parallel to y axis. Now see, this one line you already have studied into the 12th standard. I hope you might be aware of this line. Now if we are going to apply parallel to x axis, then its y coordinate will be 0. Okay, so here the delta y will be 0. Now, if you are going to apply parallel to y-axis, now if you are going to apply parallel to y, then definitely the xm will be 0. So delta x will be 0. So these kind of two paths I am going to apply here, so that we can negotiate the terms and we can find its differentiability. So first one, I am going to apply parallel to x. It means we can say that delta y will be 0. So in place of these all the terms where we are getting delta y, at that on that place you can put its as and 0. Okay, so putting the 0 you will get this kind of term. And in limits also, here actually it was given delta z tends to 0, but delta z yani ki delta x plus I delta y, and here it's being delta y equals to 0, so definitely we will get the limits delta x as an 0 form. Okay, so now this delta x will be cancelled out from numerator and denominator, this one, so the remaining term will be y. Now same we will applying for the parallel to y axis, and if we will apply parallel to y, then its x coordinate will be 0. So in place of that, in the last slides we have written the last step, or you might be have written one more step regarding like opening the brackets. Okay, so from these any steps in any functions you can put delta x equals to 0. Okay, so you will get this kind of term, and giving the simplification you will get this one term, because here you can see that delta y, and here also it's coming delta y, and denominator also it's given delta y, so it will be cancelled out. The remaining terms I have written here, and here you can see that delta y, see actually it will be I into the delta y will be 0, but I is a complex number, yani ki one of the constant we can call as, so definitely we can write delta y tends to 0. So here हम लोग लिखेंगे यहाँ पे delta y tends to 0, then you have to write rest of the terms, so it will be x plus iy yani ki 2iy. So now multiplying I on both these sides, numerator as well as in denominator, so दोनों में I के साथ multiply कर रही हूँ. Okay, so thereafter you will get the final term minus ix plus 2y. Okay, so this kind of hardest term you can solve it with by applying two parallel lines, one for the x and one is taking for the y axis. So now we can say that since f dash 0 is different along different paths, f of z is not differentiable. At z equals to 0, x 0 and y 0, definitely we can call this one. Okay, so therefore f dash 0 equals to 0 only at z equals to 0 path, and this one we have applied for the z equals to 0 path only, so that we can call as f of z is differentiable for all the values at the point z equals to 0, and rest of the values we can say that the function will be not differentiable. Now next, fourth examples I have given here. And the question is, show that f of z equals to mod z whole square is continuous but not differentiable at each point in the plane. Okay, this is a same example, it's same up to third example, and these examples you have to do in your assignment book. So as assignment you have to solve with your own self, and you, if you are having any kind of queries, then you can contact me anytime. So just try to solve this fourth one example. And today we did a new method, differentiability, and we did 3 examples. So In next lectures, in my next sessions, I will start again one of the new method, and which now it's only remaining one or two methods. So till that, please solve all the examples and do the practice. Thank you, guys.